Well, congratulations. We've made it to Chapter 2. Chapter 2 is on polynomials and rational functions, and we're going to start with Section 1 on quadratic functions and their applications. Now, a quadratic function, we already have talked about its parent function, but it's written in the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers, elements of the real numbers. A is not equal to 0. The parent function is the quadratic function, the simplest one, f of x equals x squared, and we know what the graph looks like. We know that that graph is called a parabola. Now, parabola, it has a vertex down at the bottom here at 0, 0, and in this case, this one opens upward. They can open upward or they can open downward. We're going to talk about that in just a minute. But when we have this form, which is called standard form, it is easier at times to graph a quadratic function if it's written in this form, which involves completing the square. Something else I'm going to show you in this lesson. And in this form here, f of x equals a times the quantity x minus h quantity squared plus k, vertex form, our vertex is hk. So in this form we can identify the vertex right away, which helps with our graph. Also, notice the a here. The a, if it's positive, means that your parabola opens upward. Notice here, our a would be 1. It's understood that it would be a 1 here, 1x squared, and you can see that it opens upward because 1 is greater than 0. If a is negative, less than 0, it opens downward. Now this line here, in this case the y-axis on the one I have graphed, it kind of cuts right down the center, right through the vertex. And as you can see, like one side is a mirror image of the other. This is called the axis of symmetry. And the axis of symmetry helps us with our graph. You'll notice I have 5 points graphed. I have the vertex, and I graphed 1, 1, and negative 1, 1, and I graphed 2, 4, and negative 2, 4. Because of the symmetry, I can find these 2 points knowing these 2 points. So the axis of symmetry comes into play. And also, because of the way the graph is shaped, we have either a maximum or a minimum value for our function. Now in this case, my parabola opens upward, and the vertex is kind of down at the bottom of the valley. It has the smallest y value of any point on that curve, and it would have a minimum value of 0 at x equals 0. Now, one way to remember this is a way that an old teacher I used to work with, Bob Prince, used to have his kids raise their hand, and he would say a greater than 0, and the kids would all go like this, and he would say a less than 0, and they would all go like this. And that's how he had his students remember. You need to know this because we do a lot of quadratic functions. We have an example over here. G of x is equal to the quantity x plus 2 quantity squared minus 1. This is vertex form. Even though it's not written down there, with no number in front, it's understood that it's a 1. A positive 1, so we know that our parabola opens upward. Our vertex would be kind of at the bottom of the valley. And we can answer these questions based on the information that we're going to get here. So I'm going to show you this. Determine whether the graph of the parabola opens upward or downward. A is positive, so it opens upward. Remember Mr. Prince, opens upward. A is greater than 0, A is less than 0. Identify the vertex. Well, the vertex is in the form, since it's vertex form, hk. Now notice it's x minus h plus k. So it's kind of the opposite of what it looks like in the parentheses, but it's exactly what it looks like outside the parentheses. In the parentheses, it looks like a positive 2. But this is actually in the form x minus negative 2. So h is actually a negative number here, negative 2. And it's exactly how it looks out here because this would be plus k. So this is the same as saying plus negative 1. So k is negative 1. My vertex is the point negative 2, negative 1. I'm going to determine x and y-intercepts. Now we did intercepts in the last chapter, last couple chapters actually. So to find x and y-intercepts, to find the x-intercept, I'm going to make y equal to 0. So over here, if I make y equal to 0, I have the quantity x plus 2 quantity squared minus 1. I will add 1 to both sides. I will take the square root of both sides. And I will get the absolute value, because it's the square root of a quantity squared, I get the absolute value of x plus 2 is equal to 1. So I have x plus 2 is equal to plus or minus 1, excuse me. And then I subtract 2 from both sides. So I'm going to get two values. I'm going to get x is equal to negative 2 plus 1, which is negative 1, negative 2 minus 1, which is negative 3. So for my x-intercepts, I have negative 1, 0, and negative 3, 0. Kind of going in my graph here just a little bit, sorry about that. Now to find the y-intercept, it's a little bit simpler. You make x equal to 0. So that would give me, let me bring it over here. That would give me y is equal to the quantity 0 plus 2, quantity squared, minus 1. So I have y equals 4 minus 1, which is 3. So my y-intercept will be 0, right here, 0, 3. Now I have a vertex, and I have 3 more points with my intercepts, and it asks for you to sketch the function. Those are all good points, but especially the vertex. I usually make a t-chart, and I want 5 points to get the shape of my curve. So I will have the vertex in the middle, which is negative 2, negative 1 for the x and y. Because of the symmetry and the axis of symmetry here of my graph, I will go 1 bigger and 1 smaller. I will go 2 bigger and I will go 2 smaller. Because these y values should match and these y values should match. I don't have to plug in 4 points, I only have to plug in 2, and then I'll have the other 2. So if I plug negative 1 in for x, right here, negative 1 plus 2 is 1, 1 squared is 1, minus 1 is 0, just like we expected. Negative 1, 0. That means this one is 0, negative 3, 0. If I plug 0 in, which I just did a minute ago, I get a positive 3. So not only is this one 3, but this one is 3. And those 5 points graph will help me out to sketch this. Negative 4, 1, 2, 3, 4, positive 3. Negative 3, 0, negative 2, negative 1, negative 1, 0, and 0, 3. You can see the U shape of the graph. You can see it's opening upward just like we expected. So I will graph this in a different color here if I can. And try to be neat. Use graph paper. And I get a graph that looks something like that. So there's my sketch. Now I want to know what the axis of symmetry is. The axis of symmetry for quadratic functions is always a vertical line. Back here in this example, it was the y-axis, which is x equals 0, because it goes through 0, 0 here at the vertex. My graph, the vertex, is negative 2, negative 1. So my axis of symmetry, I'm going to make it a dotted line here best that I can, is going to be a vertical line. It's going to be x equals, well, it goes through negative 2, the point here, negative 2, negative 1. So my axis of symmetry is x equals negative 2. It's going to be x equals the x value of your vertex. Determine the max or min value. Well, this is going to be a minimum because my parabola opens upward and my vertex is at the bottom, so that has the smallest y value, and that y value here is negative 1. So my minimum value is negative 1. Don't tell me that the minimum value is negative 2. That's where it occurs at x equal negative 2. The value is the y value of the ordered pair. And then it asks for the domain and the range and interval notation. Well, the good news is for all quadratic functions, unless they put some kind of restriction on, the domain is going to be, and this is function g here, the domain of function g is going to be all real numbers. You can plug in any real number. You don't have to worry about getting the square root of a negative or getting 0 in the denominator. It's a polynomial function. The domain is all real numbers. Now the range, though, is not necessarily all real numbers. The range of g, well, remember we have a smallest y value at negative 1, and then it goes up. So it's from everything from negative 1 on up, which I will write as negative 1, comma infinity. Notice that I put the bracket by the negative 1 because I want to include negative 1 as part of my range.